Now that geometry and shaders are done and all the assets are in the right place, we can concentrate on lighting. Here we have only used physical sun, but we need to add many artificial lights, like these floor lights, this kind of linear lights over here, and all the other artificial lighting. Here, for example, we will use an IS light to get this visible light cone. I already added a few lights over here. Since I needed to distribute the floor light geometries, it was more convenient to insert inside also the V-Ray light. We can move on to this interior lighting over here. We can start with organizing our lighting system. We can group all our lights inside the lighting folder. And now we can insert our artificial lights in this interior. Remember that I'm not using the V-Ray menu. I always use my V-Ray palette for faster access to the lights and tools. Now the problem is what intensity should we use for our lights? By looking at them, you just don't know what kind of intensity could be used. Fortunately, finding out these values is relatively easy. You just need to go online and you will find many similar lighting products. I just choose a couple randomly, but many can be found with a little research. When you check the technical document of the lighting system, you will find all the needed data. In this case, the color temperature in Kelvin degree and the light intensity in lumens. As you can see, there is a range that goes from 2000 to 7000 lumens. We will choose a middle range value because in this phase it doesn't really matter to be too precise. We just need something plausible. Let's go back to Cinema and now we can insert our data. The light dimension should be around 20 for 150 centimeters. So in the dimension slot we will use half the dimension since it's a radius value. Now set the unite to lumens and use about 3500 lumens. And now we can insert the temperature in Kelvin degree. It's not a warm light, so it should be about 4000 Kelvin degree. But I feel that Cinema 4D built-in Kelvin scale is slightly off, so I always prefer to move slightly to higher values. So I will use 5000. Later I will show you how to be more precise regarding the temperature using the frame buffer preset. Looking at the lights, they are distributed in various rows and with a slight offset. We can always use a cloner for distribution and we can set it in honeycomb mode. They are obviously too many. Let's fix the direction, the number and the offset. That should work now. Let's position them at the right height and then we can move our lights in the interior. They look okay, but they will need some more tuning. We can make the cloner editable. Let's call this group interior light 1 and let's move the lights where we need them. That should work. Now we can see these floor lightings. In this case I always use a cloner to distribute them. I use 2500 lumens. I also use a little bit of directional light and always 5000 Kelvin degrees for the temperature. Even for these floor lights, I use pretty much the same values. Later we will see how to add these IES lights over here. And now we can see how to add this kind of linear light up here. Linear lights can be inserted in various ways, through light material or simply through a self-illumination channel of the Vray material. But these options are not optimized for the sampler, therefore I tend to avoid them whenever possible. Since in this case I have an almost linear situation, I prefer to distribute some simple area lights instead. I already copied them from another file. You can see some of them are distributed here. In reality, this will probably be LED stripes. So for intensity, you can start with something like 1000 lumens for every linear meters. So for about 10 meters, we are going to use about 10,000 lumens. These lights will be hidden behind the frosted glass. Of course, these are just general light values, as LED stripes can vary a lot for both intensity and color temperature. Now, don't worry if you don't see these lights clearly. As for a daylight rendering, the interior lights will be barely visible from the outside. Of course, for night views, the effect will be totally different since we are going to use another camera exposure. Since we mentioned the physical camera, let's talk about how to use it for the image's composition. For example, in this project we have very dynamic lines, and personally I like to make them even more dramatic by using a wide angle. It's important to position the camera in the right spot, always trying to find lines that will guide the observer. For architectural shots, usually it is best to not have a vertical deformation, so always put 0 on the y-axis. Here, for example, we can use these two diagonals, the metal grid on the floor and the top right corner of the building. If needed, we can also tune the position of the two diagonals using the X and Y film offset, so that the lines start from the corners of the image. Here in this image we have our guidelines and this large neon installation that will enrich the composition. Here we have another view and we follow the same principle. The wide angle is even more extreme because we use an 18mm focal. Be careful because when you use such extreme angle, the vignetting effect will be a lot more visible. So you should take care of it if you don't want it. Still talking about composition, here we can see the shadow of one of the street lights. This is something that might work since it will fill an empty area of the pavement. For example, something that I do frequently is to add the shadows of trees on empty fields of grass in order to make the composition more interesting. But in this case, if it is too distracting and you don't like it, you can just modify the composition by removing the element. I think it is very useful to write the frame ratio next to the name of the cameras so that you know what render settings to select. It is extremely important to choose the right proportion for the image. That could be horizontal, vertical, square or whatever. You need to test them and see which one works best. Here, for example, we have a similar point of view, but with a different focal length and different proportion. As you can see, the image fill is totally different. As I already mentioned, the vignetting effect in this case is less visible, so you need to keep it in mind when you work with your image. Now we added our physical sun and several artificial lights. We still need to add neons and IES lights, but first of all, let's test another lighting option using an HDR sky. Let's turn off the sun sky system. We can simply add a dome light where an HDR texture can be loaded, but I prefer using a custom setup that was kindly shared by Unal that not only has all the dome light functions, but also other features that I will show you. When you load an HDR, you can see it directly in the viewport. You can set a custom brightness since not all HDR images have the same intensity. You can also control the scale and rotation. It is really an extremely useful setup. Now let's call this HDR overcast. Let's insert it inside our lighting folder and create a new camera for this light. If we start the render, you will notice it is very dark. A cloudy sky is a lot darker than a clear daylight sky, so we will need to adjust the camera exposure. And now it works. Now we can move to our neon light. Here I used Vray material. This is very simple with a little reflection, a white color and a gray color in the self-illumination to fake a bit of translucency. Now it is time to increase the intensity of the self-illumination in order to make it more visible. As you can see, it is a lot better now. Let's move closer. And it works really well. I could have also used light material, but in this case a V-Ray material was the best choice since I needed to show in both on and off mode and also with some reflection. We can use now another HDR. It is a foggy sky. Go back to cinema, duplicate the previous dome light. We will call this HDR fog. And we will load this new image. We can always fix the rotation of the HDR so that the brightest part will appear in this area behind the building. And this will help us in creating a greater contrast between the building and the background. Start the render. I will also turn on other floor lights that will help enrich the composition. Probably these bright lights over here are a little bit too bright and add too much contrast to the image, therefore we want to turn them off. This will give a chance to see a new feature of the latest build of V-Ray, that is the light lister. From this global panel, we can turn on, off and calibrate all lights of the scene. We will turn off these lights up here. By turning off these very bright areas, the building silhouette is a lot more visible and contrasted compared to the background sky. If we look at our HDR, we can see there is fog. Therefore, we can also add it to our scene through the use of the environment fog. Our fog reaches just 1 meter from the floor. That is very low, so we are going to increase the height quite a bit. Now we'll see only black because the fog is too dense, since visibility is set to 10 centimeters. So we need to increase this value a lot. We can try with 10,000 or 20,000, and now it works much better. We can probably turn these lights over here back on in order to avoid such a dark area. And now the image works nicely. We can create another type of lighting using a blue hour HDR, and we will also add these IES lights here in the ceiling. Duplicate this floor light we already have, and we will distribute it along the spline using a cloner. Position the spline at the right height. Set cloner in object mode, choose the right rotation, and set distribution on even. Now we can create an IES light, and with the transfer tool we can position it on our ceiling light. Then we will put it here. Call it IES light ceiling. And select an IES file. Create a new camera. Duplicate the dome light. I will call it blue hour. And then I will load a blue hour HDR image. Fix the rotation and start to render. Here I forgot to turn some lights back on, and I can do it right away through the light lister. Now our scene looks a little dark. We need to fix the camera exposure a little. Now we can move towards our ceiling lights. We can see they are very dim, so we are going to increase the power here. Let's try with 10,000. We notice we have two issues. There are no visible ceiling lights, and the light cone is not positioned correctly. We need to move the light source closer to the wall. And now it is more similar to the reference image. We can also fix intensity and temperature, and now we can add also an extra rectangular area light to simulate the visible light. We can give it a certain value in lumens, temperature and dimension, and turn on this shape option, since it is a round light. Naturally, it will need to be visible only to the camera and not bring light to the scene, so we can disable all this option here. Now you will notice that the IES is not lighting our scene anymore. That's because it is behind the visible light. We can fix this quickly by raising the visible light by 1 millimeter. Let's get closer and we can see this beautiful light cone from our IES and the visible lights here on the ceiling. We can also activate the lens effect. Let's go back to the main camera and see the final result. Let's tune a bit the tone mapping. And we are done. We have a nice blue hour mood. We could also create a night blue hour mood using directly the physical sun sky, since the improved sky model can let us simulate also night skies. Duplicate our physical sun sky. It is way too bright for the camera exposure, but if you just move it under the horizon and position it correctly, you can get a nice night sky. Probably it doesn't have all the nuance of an HDR image, but it's still a good option nonetheless. We can now see what can be done through the use of frame buffer. Let's open Vray render elements, select light mix, and cryptomatte render elements. Then start a render. We can start without any tone mapping. As you can see, the image is a little dull, but it is a linear render, therefore it is supposed to be like this. For first thing, add an exposure layer to compress the highlights. In this scene, highlights are not too extreme, but it is always a good starting point. Then add the filmic tone map. You can tune all the settings if needed. Here we will use this Agile Dawson type, as you have a nice control over the shadows. And finally add the lookup table, where I will add my Kim Amland LUT file. There is obviously a very noticeable difference with the image without tone mapping. For a small adjustment, you can modify the exposure directly from the frame buffer without changing the camera values. And here we have a beautiful render with nice contrast. Since I added light mix to my render elements, our source image is already set to light mix and not RGB, and it includes all our lights. If we want, for example, to turn off these raw lights, we can do it without having to re-render the entire image. Light mix not only enables you to have total control over every light, but it also enables you to make extreme changes if needed. Like if you want to change this overcast sky into a night sky, you can do it. Just lower the intensity and select a bluish color for our sky. A little side note about the color temperature. As I already mentioned, Cinema 4D built-in system is not that accurate. I found that preset values from the frame buffer are a lot more reliable. So select a blue color and adjust tone mapping slightly. As you can see, we transformed a daylight scene into a night scene within seconds. There is obviously a lot more stuff you can do through light mix and frame buffer, but time here is limited, so we can just have a taste of what can be done. Under source, we don't only have RGB and light mix mode, but also a composite mode where we can also modify all single render elements and do amazing things. This latest version also introduces the batch image processing option that lets you load animation sequences. Here you have the input folder to load your frame sequence, here an output folder to save them, and the layer preset to apply your frame buffer corrections. With Vray version 5, the VFB has become an extremely powerful tool for post-production. From my experience, the image correction selected through the frame buffer are already finalized or may require very little tuning with other tools. Let's see another image. We already apply our basic tone mapping. We can add a little bit of contrast, play with highlights and exposure. Then add a white balance layer to remove a bit of blue tint from the sky. We can also saturate the image a little to make it more vibrant. In the new version we have also a super useful tool that is the Sharpen Blur layer. Personally, I'm very happy with this new entry because sometimes I use Photoshop just to add a bit of sharpen, and now I can do it straight from the frame buffer. Let's zoom in and see the difference, with and without this layer. The parameters are very simple and intuitive. We have amount, radius and blur. Now we can see something different. We can modify single material with the use of cryptomatte. On older Vray versions, if you wanted to adjust the saturation of this tree, for example, you needed to create mask, save the image, open the image in an editing software, loading the mask, and finally modify the saturation. Now it is a lot easier thanks to the integration of cryptomatte inside the frame buffer. We have the render elements over here, and all objects have different color ID. To use it is extremely simple. Choose, for example, a hue saturation layer, then add a cryptomatte mask. Choose the picker and click the elements you want to modify. Here you can also see them through a mask preview. If needed, you can also remove these elements through the picker or minus button. Once we selected everything, click on Properties, and now you can lower the saturation. Let's see another example. Let's create another hue saturation layer with cryptomatte mask. Select the fire hydrant. And we will totally change the hue of this object. You can choose whatever color you want. And now we can save our image. Normally I save directly in TIFF format since 99% of correction are done inside the frame buffer. But if you would like to have more control in post-production with other tools, you can save in VR image format. That will include all render elements in 32-bit format. Now we can open our image in Photoshop for a bit more tuning. Under Filter, use Convert for Smart Filters so that the corrections are non-destructive, then apply a camera raw filter. I always start with auto correction, that usually gives good results. Then if needed, you can tune a bit more the white balance, maybe even a little more sharpened to get a super crispy image. And we are done. It takes just a few seconds. Post-production is something extremely personal and depends on your style. There are people that prefer to do a lot in post-production, or others like me that barely use it. Of course, this last part in Photoshop is totally optional and up to you to use, as the VFB is more than enough and gives you a lot of control over the image. Here are a few more images. I love this museum, so I'm sure I'll continue having fun rendering more views and adding more details. Well, We started from the CAD file and ended with the final render. So I guess that's all for today. Thank you very much for following this workshop. We naturally try to share as much information as possible, but there is only so much that can be done in a couple hours. We wanted to thank the Chaos team for this opportunity, thank to my brother Sirio for taking care for all the on-site photos, and obviously D2 for hosting this event. We hope you have enjoyed this workshop, and we will see you around for other amazing Vray stuff.